everybody, Dr. Fever here. In this short video series, I'm going to introduce some of the basic terminology and techniques that you need in order to start doing mathematical proofs. If you're new to this sort of thing, it's going to sound pretty out of the ordinary, but as you watch these videos and do more practice with proofs, this will all start to come together and make a lot more sense. For today, for this video, we are going to talk about three things: statements, axioms, and hypotheses. So statements. Statements are things that are either true or false. I know that sounds strange when you first hear it, but we'll do some examples. It'll start to make more sense. So two examples of things that are statements are elephants are mammals and elephants are viruses. Both statements, elephants are mammals is true, elephants are viruses is false. So they have a truth value, meaning that they are either true or false, and that's what makes something a statement. Here are 5 examples that we're going to go through. The first one is the question, how do you do? And this is a question. Questions are never statements because a question cannot be true or false. It's not telling you information, it is inquiring. The next thing we have here is x equals 4. X equals 4 is a statement. It could be true or false depending on the situation, depending on the problem you're working on. And it's okay that it can be true in some situations and false in other situations. It's still a statement because it has a truth value in any given situation. Next up, we have do not eat the soup. This is a command, not a statement. If you ever see something that's a command that's telling you or someone or something to do something, then it is not a statement. Next up, we have YOLO. This is a statement. It's either true or false, and I know some of us would say it's true, and some of us would say it's false. There are some people who believe in reincarnation and think you live more than once. Some people think you only live once. But the fact of the matter is, even if we don't know the answer and cannot prove the answer, it's still a statement because it still is either true or false. And last we have, are you a cat? This is a yes or no question. You are not a cat. Even though it can be answered with yes or no, that's not the same as it being true or false. Questions are never statements. They're inquiring. They're not telling you something. To wrap things up, a statement is something that's either true or false. You don't need to know whether or not it's true for it to be a statement. It just has to be something with a truth value. In fact, something can be a statement even if nobody at all can determine its truth value. If you're asked to recognize something as a statement, you do not need to prove it or understand it. You simply need to determine whether or not it has truth value. Next, we have axioms. An axiom is a specific type of statement that's commonly accepted to be true and self-evident. So when I say something is self-evident, I mean it seems to be obvious, and that most people agree that it's obvious. So one example of an axiom from the ancient Greek mathematician Euclid is that two parallel lines never cross each other. If you look at two parallel lines, they maintain a constant distance from one another, and you can say that it seems obvious that in geometry, two parallel lines will never cross. Of course, someone has to decide which things are considered axioms and which things are not. They are generally agreed on by the mathematical community, and a couple of properties that axioms have is that, in addition to being clearly true, they can't contradict one another. And axioms also cannot lead to conclusions which are clearly false, because that would indicate there's a problem with either the axiom or your logic to begin with. Here are 3 more examples of axioms just to help solidify this concept. And these are also from Euclid, the ancient Greek mathematician. So lines are one-dimensional, right? They have no height, they have no depth. Second, things that are equal to the same thing are equal to one another. So that's just like saying if x is 5 and y is 5, then x equals y. And a third example is the whole is greater than its parts. For example, since 7 plus 3 equals 10, then 10 is greater than 7 and 3, which are the parts that make it up. One thing to be aware of with axioms is that if you see one in a course where you're writing proofs, you should never try to prove an axiom And you shouldn't try to take the time to explain why it's true. You just accept it as a fact and use it in your proofs. The last type of statement we're going to discuss in this video is the hypothesis. With the plural of hypothesis is hypotheses with an E where the I is. A lot of students get this wrong or will try to write things like hypotheses. Hypotheses are also known as assumptions, since they are statements that you assume to be true, even if they're not. You only assume it's true for the sake of a mathematical or logical argument, so you can follow a line of reasoning that happens if the statement were to be true, if the hypothesis were to be true. So, as strange as that sounds, we do this conversationally as well. So, for example, say you asked one of your friends, if you had 10 arms, would you be a better rock climber? If they play along, they would answer the question assuming that they have 10 arms and tell you what would happen. So in this case, having 10 arms is the hypothesis, and the person that's answering your question drawing conclusions based on that hypothesis, even though they do not and never ever will have 10 arms. A more mathematical example, let's take the sentence, if in this equation x were equal to 2, what would y be? Here, the hypothesis is x equals 2, and even if x is not 2, you'll answer the question as if x were 2. So you're going to answer the question based on the hypothesis. So, to recap, hypotheses are assumptions, things that you assume to be true, even if they are clearly not true, for the sake of an argument or a line of logical reasoning. So we are done with our 3 types of statements for this video. And to summarize, this video covered 3 things: a statement, which is something that is either true or false; an axiom, which is a type of statement that is obviously true and most people would say is common sense; and a hypothesis, which is a statement that you're asked to assume is true for some line of logical argument, even if you know it's false.
That's all I'm learning. Hope that